Let's just define sound intensity and sound intensity level beta in decibels. Kind of slippery sounding, similar names, but intensity and sound intensity level are different. So sensitize yourself to that. Okay, suppose you had some music playing, and so you got a loudspeaker and waves are coming out of it. Those are pressure waves, and you can measure those with some kind of pressure gauge, or we call it a microphone, I guess, is what we call that. And this microphone is, you can hook that to a voltmeter. You could plot a function of pressure with time if you want. And so you might get it, if it was just a single tone, you'd get a sine wave over time. And that's going to have a maximum pressure and a minimum pressure, but it's going to hover around gauge pressure 0, which is just the ambient air pressure. And so let's take just the positive part of that, and we'll call that from 0 up to the top of the wave. We'll just call that a delta pressure. And we're going to use a lowercase p for now, just for purposes of these few minutes. Because your sound, your intensity, wrong color, let's use blue, intensity is given letter I, and this is any intensity, and it's the delta pressure, lowercase p, squared over 2 times the density of, if we're in air, it's in air, the density of air, and then the velocity of the wave, 331 meters per second. So the air density, we can look that up. I think it's 1.22 kilograms per cubic meter. And so so you stick this this is the amount of power per square meter. So it's the power passing a 1 meter squared surface. And it does, so it's got to have units of power, which is watts, and then per square meter. So the units are like that, or if you don't like watts, a watt is a joule per second. So you could write it as joule per second dot meter squared if you want to. Well, that's intensity. That's all there is to it. It is power. There is power in sound. Usually for human hearing, that's not very much power. For other things like earthquakes, okay, that's a lot of power. There's another thing before we quit defining things, and that's the sound intensity level. And I'm going to give that the symbol beta. And it's got units that are quite funny, but they are traditional, so we're going to learn them. That's the decibel, so the units are in decibels. So beta, with units of decibels, is a factor of 10, just a constant, times the 10 base logarithm of the intensity from here, divided by a reference intensity that we're going to call I naught. So I naught is a constant, for one, and it's equal to a trillionth. So 10 to the minus 12 watts per square meter. So that is that's a reference constant, and it's operationally defined. So approximately this is the threshold of human hearing. So in the limit where this microphone is actually the human ear, can we even hear a sound? The sounds, the faintest sounds we can hear are about a trillionth of a watt per square meter. So the threshold of human hearing, and to be specific, that has to happen, or is defined to happen at frequency of 1 kilohertz or 1000 hertz, like that. So that is that's what I naught is. So it's a constant. So anything louder than that, this ratio in this definition is going to be greater than 1. But if it is exactly 1, what happens? We've got 1 in here. So trillionth divided by trillionth is 1. Then we take the 10 base log of 1. Now that's an interesting number. Logarithms are, if you're not used to them, they're kind of fun. They're the opposite of the power of 10. So if you want to take the anti-log, what you do is you take 10 to that power. So 10 to the power 0 happens to be 1. And so the log of 1 is 0. And so at this threshold of if I is equal to 10 to the minus 12 watts per square meter, that's the same as I naught, so this ratio is 1, and beta is 0 in that case. You can get less. So suppose that's a tenth of I naught. So it's 10 to the minus 13. So you get 0.1 in here. You take the log 10 of that, and it's log of 1 over 10 is minus 1. And then you multiply by 10. And so you get minus 10. So if it's 10 to the minus 13 for your intensity, then beta is minus 1. And it's symmetrical it's open-ended. You can go forever, either direction. And if it's a little greater, say it's 10 to the minus 11 watts per square meter, then beta is a positive. Did I say minus 1? I meant 10, because there's a 10 here. Oops. So let's do that one again. So if that's a tenth, you take the log of it, it's minus 1, then you multiply by 10, so it's minus 10. And then if this happens to be 10 times greater, so that's a 10, then you take the log of that, that's 1, and then you multiply that by 10, so the beta is 10 in that case. So the logarithms are kind of funky, they're open-ended, and we call these things decibels. So 0 decibels, minus 10 decibels, and 10 decibels. So a little d and a big B for the abbreviation for decibels. So each factor of 10 in decibels is a factor of 10 in intensity. So it's convenient. Once you get used to it, it actually makes a lot of sense.